So we are dealing with convection now. Free convection in air, right? Remember, we're talking about the still medium, right? With the medium air, it never will be purely conduction. Because the air, once you have temperature difference, then the convention when it's flow. But the water, sometimes we only deal with the pure conduction. That's the thing. The object is steam hot water plant, right?
Oh yeah. Okay,
Burning in the steady air. So the medium air
That's
convection.
There's multiple.
We have the temperature change over time.
There's also
The whole plant is isothermal, so you can apply the anti-bends for the bulk, right? Most likely.
The answer for
The question asks you to evaluate the convection coefficient or external coefficient H, right? For convection, that's the solving H. We give you the dt over dt simple, right? Temperature of the substrate giving you. Temperature of air giving you. They give you all dimension materials giving you the specific heat, right? The first, I think the first part is neglect the radiation, right? Get the answer. The second one, if there is radiation, get the ratio of the convection heat loss by radiation and the convection. Very simple. So, any volunteers? Very good. You prefer use the marker or camera? Marker over there. Oh, some small item missing in every teacher room. I don't know why.
Okay, so just think that this is plate heading around the surface. This one will be 498 Kelvin. Because it's 225 plus 273. Then given you specific heat will be 2770. Your mass. Okay, your mass is 3.75 and your area, if you calculate right, will be 0.3 times 0.3. I just do this one first. Then, because it's multiple process, right, we have to use this formula, which is E in minus E out goes to the system. So with this, right, then first time we use convection, right? So convection 2 HA as the AS is the 2.3, TS minus T infinite goes to this one, right, can be seen in the lecture notes. So this, if I say this part, right, this part will be rho VC VT over the small t. So this part will become MC VT over VT. So now I want to find what's H. So if you tabulate everything, right, you find the
Just one minus in. The purpose is giving you the dt over temperature, the gradient. dt over dt is negative value, right?
negative value.
Yeah. Then that means you will calculate by H also will be negative.
Yeah.
Right? But the external coefficient cannot be negative, right?
Yeah.
So which part is wrong?
The temperature?
Let's put negative at the E.
Let's say E out have negative sign in front of that.
Negative E is minus.
And
So it must be a minus 2. -2H. Yeah, minus 2.
Minus 2H, yeah, the minus sign there, right?
Then you will neutral.
Yeah.
Okay, so then next will be the radiation because they want to compare the radiation with the convection, right? So normal formula you just use the so with this one right, you'll get about 243. So it's not achievable.
To just compare with the class for convection. Like good. The fundamental.
Then
Okay, very big answer. So go to Patrick. Schematic, right? They give you the temperature change rate. Definitely apply the end balance equation for the box, right? For the assumption, it's always the same. We don't need to solve for information. Set state, right? But because this is end balance equation for the whole box, we have another assumption, isothermal, right? See? We are dealing with not purely conduction. We don't have 1D H conduction, right? That's assumption, right? As I mentioned, those 5 or 4 assumptions is universal, but sometimes it's not applied. Then that's remove that, right? So energy equation, right? We don't have energy in, right? We only have energy out by convection. When you get the radiation, right? The no generation we only have storage generate, right? Try this one. Everything low except the H. Simple, right? Get the H. Remember when you write down the original equation for three law of transfer, right? Also the energy equation. Remember the sign is very important. The second part we know radiation, talking about the radiation heat loss, right? Just compare against the result, very simple. So we go to question 4. Okay, the type graphs the geometry quite similar. Given temperature, is cooling by convection, right? Of air, giving you the H, so we know it's a free convection basically. This is few technical descriptions about the most fun part. So we know the temperature gradient. Actually, it's the maximum temperature gradient, right? Another thing I also need to notice. When you do the calculation, it's better using SI unit than need for temperature or using Kelvin instead of degree Celsius, right? But because they actually the magnitude are same, it's the temperature difference in Kelvin and the degree Celsius are same, right? When you encounter the temperature difference, doesn't matter you using SI unit or using degree Celsius, it's fine. But when you deal with just the number of the temperature, we're using the Kelvin. Better using SI all the time, right? Otherwise, we have trouble. Given the material properties, the conductivity, giving the infinity, right? This actually ask the question asks you about the T infinity temperature, the temperature of the air, right? Also, they assume the temperature of air equals the temperature of surrounding, right? This problem is exactly the same with this one. Right? Just the glass plane, you have two surfaces. For each surface, you at the end have conduction equal to apply surface energy for the surface, right? Okay. For the actual question, you have two surfaces, right? Conduction equal to the convection plus radiation, right? That's that thing. Anyone else? You don't even camera or the
他是跟我一样，他不是不懂怎么做。你跟我一样哎，不懂怎么做哎。不是翻译，不懂。You need to explain.
你看先哦，那个我放。
原来我要 solution. You don't do persuasion.
这是 solution 的，这是 solution 的。
the also
你不要 pass presentation 吗？
Yeah, 不到
来 pass your paper 那些 question 呢？然后 percentage transfer。send us
Yeah, so
last 2 sem.
so we have the glass at 600 degrees Celsius. So the first thing I did is to change all my units into SI units. So I have the temperature in kelvins and also the temperature gradient into kelvins in meters. So then after that, it's just simply writing the equation without area because area is not given. And yeah, so the equation would be non-linear and it cannot be solved. So you have to, I solved it using numerical methods, just by iterations. And you will find, I find that the answer is about 618, it's the closest I can get. It's about 345, yeah.
Just a polynomial equation, cannot using a calculator to solve that.
Yeah.
Oh,
Cannot.
because I never using calculator, I don't know what it is.
Yeah, because it's a power of it's a power of 4 here
Yeah, understand.
and power of 1 here. You can't solve it.
Just one problem. When you apply the energy equation, we're also using H rate instead of H flux. Using capital Q, it's better with the surface area A involved. The one thing. The other thing, when you write down the Fourier law, they always have negative sign here.
Negative.
Meaning this equation.
Negative side.
Here.
Yeah, they always negative sign.
Okay.
So what's the reason? Because dt dx is here in negative.
Sorry again?
I mean the temperature gradient, dt over dx
Yeah.
is a negative value.
Okay.
Then combine it becomes positive,
Okay.
right? But you cannot neglect the negative value, right?
Okay.
Just to show you understanding of this. Very good. Okay, so here.
But then the degree thing, right? The 15 degree millimeter, right? When
Yeah.
you change to Kelvin, isn't it plus 273?
Sorry?
The 15 degree.
No. Then
no need,
temperature change, different temperature difference.
Temperature. So even if I change, I don't need to add the 273.
No, because you add the constant value, then divided by something that doesn't change at all. Because it's dt over dx, right? The temperature change is delta t. But delta t doesn't matter if degree of Celsius or it's Kelvin, it's the same.
Oh, okay, sure.
You might do.
I was keep thinking how to convert. I keep thinking how to convert.
Just the thing, wherever you encounter the temperature difference, not necessary to change the from degree Celsius to Kelvin, but it's the purely all solid talking about the temperature, so we're using Kelvin better, right? But also it's fine wherever you encounter temperature, just use Kelvin. Nothing wrong. Okay, we're going to last one. Same line, likely a little more complicated. I don't like discussing with a very long text part to describe the formula. Okay, it's a solar panel, right? To give you the incident energy flux, energy transfer rate. Oh, incident energy flux, because you see the unit is volt per square meter, right? Does it actually give you the smaller Q dot?
肯定对的。
It give you the area, give you the how much does the energy actually
Let's say that the
be
radiation
stored.
come in, right? Then 90% of it is
Just
and
the
10%
same thing.
reflected out. Then the
And
rest is
then you solve the
radiation,
2% is reflect away.
convection and
Water
radiation.
getting into new temperature after another temperature.
不用这么麻烦
This is the solar panel heating up the water.
讲的
I'm not sure you see this equipment before. There's a lot in, I understand, I'm not sure about other countries, but in China, there's a lot of device. You put on the roof, to heat up pipe, then you get the water heated for the shower.
Before table concept participation.
Okay, the cup glass, they have some temperature giving you, humidity giving you, the radiation for the sky giving you.
Sketch.
Here you should notice the T20, when you calculate about the convection, it actually is 30 degrees Celsius, right? But the T surrounding we can by radiation. It's not a temperature. Most likely you will encounter the cases that we assume the T infinity equal to T surrounding, but this one is different. Remember, convection heat loss is formed surface to the surrounding air. Radiation heat loss is formed surface to the infinity. Right? That's the difference. They give you the H already. Oh, sorry. T infinity is 25. It's the ambient air temperature. It's the TS actually. The question asks you about the overall energy balance,
is
right?
the sun going in here. Right, 90% is
Asking you about the QU, the U for
and the
flux.
rest is just normal equation. Then you can answer it.
Then care about the temperature. That's the actually how the function
is a
of
different type
the
of convection.
this is called water
Now
heater.
is when data is use this
Solar water
conventional way.
heater.
Then
Okay.
you see the
So you
efficiency.
can define the is the collector efficiency and carrier value. Right. The thing completely, but still the concept is quite simple. Any volunteers?
Those who wish
Very good.
to success the right
Sorry?
Question 4.
Question 4.
Question 4, okay. I didn't show you?
No.
Oh, sorry. So later, just 1 minute. Okay.
Okay, I'll take a
Just a schematic, right? Schematic assumption, very common schematic. It's very, very simple because just apply any balance for the surface energy equal and out. Animation I will have negative sign for Fourier law. Only T surrounding we don't know, right? Because here, remember T surrounding equal T infinity, right? For next question, they are not equal, right? Everyone take photo already?
No. Do you mind if I use the projector to show?
Sure. Everyone done? So we go on? Sorry? Scroll down. The rest just the discussion with something else. Yeah. Again, what I'm showing now is not the standard answer, it's my summary of the answer, my own understanding of the answer. So, that's why we're looking at the standard answer. I cannot totally agree with the standard answer. So something not necessary to show, and something quite a misunderstanding. Okay, that's okay.
This one we don't know.
But we do 1, 2, 3. Cannot. Then 2, 3, 4.
Then how you
Uh,
how you do this one?
Because I think that our responsibility is slightly different to lecture.
I
Lecture you have
do the
to
convert
get the overall understanding of the course. For the tutor class, my responsibility is help you to perform better in the examination and quiz. So it's better you get you know the marking regime, you perform better, you get better result. I know this rumor, this course is called a killer, right? Lots of people fail.
Yes.
I don't want it to happen in my class, so I try my best to help you pass, right?
Is question 4 type of question common in exam? Because it's quite
Yeah.
time consuming
Uh,
for calculations. That's just a concern.
yeah. Just because I never encountered such case in the quiz examination. That they don't require you to discuss. But after you do the calculation, that's done.
Not the discussion, but the reiteration.
The
trial
trial.
and
Oh,
error
I know.
is quite time consuming.
Usually because that's the homework. You can do it at home. You can do the programming using the software and do that. But during quiz, you cannot do that, right? That's the only occur during quiz.
Okay.
Definitely, no one brings quiz into quiz, right?
But finals it happens
Okay.
before. Right, finals it happens a lot of times. Solid Mac thermofluid thermodynamics
Okay.
那个老师说会出啊那些老师说会出，
那些老师啊，
这个老师好像没有说。
是不是老师吗？那个
I
那
mean
个
课改就给他上个三个三。
很赶，就在一步就到了，很赶。
这个 question 上3个项也是有。
No, last time. This last time. This
Okay.
question is last.
Wow, they never share.
So this question is a
我没有
very long one with
在
a
家
lot
里
of information.
我说我 weekend 才可以 send。
Basically, at the very top, I summarize all the important information that you have to take note from the question. Where the heat flux GS, which is actually the small letter Q with a dot on top, is equal to 700 watt per meter square. Then, another thing to note is 90% of the Q in of the heat input is actually absorbed. The glass surface is 30 degrees Celsius, which is equal to 303 degrees Kelvin. The area of the surface is 3 meters square. And then the water is heated from Ti to T naught. Then here are the relevant information with the modulus E equals 0.94 surrounding temperature, as well as the ambient temperature and the convective coefficient of the glass. So the first part asks you to perform an overall energy balance. So basically it asks you to find the QU dot. So the first step in which you have to do is you have to calculate the actual Q in that's absorbed and subtract the amount that's reflected. So basically 0.9 times 700, which is equal to 630. Then you apply the energy balance where Q in is basically equals to useful heat collected, which is QU plus convection Q and radiation Q. So it's basically energy balance E in equals E out. Then upon solving each of these relevant values, you can actually find QU, where this part is actually the convection equation, and this part is the radiation equation. You solve all the relevant values, then you should get 386 watts per meter square. Any questions? Okay. Second part is they ask you to calculate the temperature rise of T0 to T1, where they give you the flow rate of 0.01 kg per second. Take note that the flow rate is actually the flow rate of all the tubes. If the flow rate is actually the flow rate of one tube only, you have to multiply by 3. So by the first law, you just take Q equals to MC delta temperature, which is equal to T0 minus T1, final minus initial. QU is basically useful heat collected per unit area of the collector. Times 3. Oh yeah, you have to multiply by the area
Yes.
to get the overall heat energy absorbed from the small letter q to large letter q. Then you equate it to MC delta theta. So after you get all this, submit all these values, you should get T0 minus Ti, which equals to 7.7 degrees Celsius. Okay. The last part is where they ask you to find the efficiency, which is basically the ratio of useful heat over the total solar energy. Useful heat is the amount of heat collected, which is QU, which is 386 as calculated from part A. The total solar energy is the total amount of energy incident to the contraption, which is 700 watts per meter square. So you get a ratio of 55.1%. That's all.
Okay, very good. Okay, just one thing. You're missing one important part. Because the principle with Martin show, we just want to know your understanding of physics. The one thing the missing is when you apply the energy balance equation for the bulk of surface, here actually the same.
Cannot see. Yeah,
Oh.
cannot see.
That's okay. The first part actually, you didn't apply the original energy balance equation, right? You directly show the energy in equal to and actually this QU here, most likely is not the energy out. It's actually the E generation, but it has a negative value because you have the solar and the heat come with absorb the heat. You use the heat out the water. The water actually get out. So we consider as the E generation, but with the negative value. Because one component, yeah. I think also
Can we E stop?
because we consider about the Q out, most likely by convection or radiation, right? Or also by conduction. But here, energy, the water get in cold, with the low temperature, get out with the higher temperature. Mostly we consider is that E generation, but with negative value.
Like, shouldn't be considered like E out, like energy carried out by mass? You know, that's like,
Because when you have a control volume, you won't consider there is a mass transfer, right? Only for heat transfer. When you consider mass transfer, that's not closed system at all, right?
yeah.
That's the thing. But when you write down the equation, it should be exactly the same.
Yeah.
But let's show you the understanding of physics here. No difference, right?
How about writing it as the rate of change of the energy in the system? So it's the
Because it's, the thing that rate of change is the temperature change over time, energy change over time. But here it says that the no change over time. That's the thing, right? With the rate of change is temperature, energy change over time. But here it says it, right? I think both are fine. I think the final equation we write down the same, only the original energy balance equation may be slightly different, right? Of course, I do prefer we will write down the energy balance equation better using the capital Q instead of smaller q, because then you show you amount of energy. Otherwise, you show the amount of energy per unit error, right? That's the difference.
But the question asks for more energy.
Yeah, exactly. Yeah, sometimes we do that. Anything? Found anything?
All right. That's all.
Even for this one, sorry, there's a comment. Even for this one, despite the question, the problem is very long. But actually, they give you a schematic, right? But that's not very good schematic. You can actually draw your own version of schematic, much simple. All this container can be removed, it doesn't matter, right? Your closed system, you get energy out, right? You have E generation equal to negative value, or you have container as a Q out, doesn't matter, right? That's not a schematic. They just show you the roughly what happens, right? You should draw your own version of schematic. Because like here, we consider roughly is schematic, right? But here that's too complicated. When you during the quiz exam, if you try to solve that better, but you draw your own version of the simplified schematic, right? But too complicated. Some components are totally unnecessary, right? Okay, I'll show you my answer. Again, the standard approach, exact same thing, right? Because given too much information, I cannot list all the given information, right? Just focus in for the solar cycle. I think that's just what they call the solar panel for water heating, right? Let's see. Now what are the following few things? First the QU and the temperature difference, and the cluster efficiency they defined, right? Basically, once you solve in get the QU, you get everything. Again, this is the energy balance for the. That's why we prefer to write down the energy equation, the original energy equation. You substitute every item. Otherwise, you can directly give you the second one is fine, but you might lose some points like this, right? So substitute everything, you get the answer, exact same. And as I mentioned, the calculation step is not important. You can directly have here, have the equation, the original energy balance equation, get the specific case, right? Then directly give the answer. Even between the few steps of the derivation, you don't need to show in the paper, not important. I know everyone has the capability to do the calculation, not important, right? Also, for me, the final, if the final answer, the number is not important. Most likely, you're choosing the right formula, right? Show your capability show your understanding of the problem. The rest doesn't matter. I think that's the number. Only thing about left, I think 10% of total credit. No, that's the total.
No need to iteration. There's two parts.
Okay, the second part is just they ask you to measure temperature difference, right? That's the energy balance equation, right?
This is correct. Already, you still get pass one.
Just remember the thing, because in over this course, last part, the talking about the collecting basically, again, but once you get a QU, you get everything. Because the heat flux and heat transfer rate, they have the dots on top because we're dealing with the heat transfer, energy transfer per unit time. Because through this course, we're always dealing with the temperature, the heat transfer per unit time. So we just can remove the dots on top. That matters, right? Because in other courses where you have the capital Q, the unit is not a watt. The unit always is joule, right? So that's the difference. Because in heat transfer, we're always talking about the capability of heat transfer per unit time. So we don't need the necessary to add the dot on top. It's okay, you keep the dots is fine, but might cause some trouble if you have other form of the misunderstanding, right? Okay, that's roughly content of today, so I'll see you next week. Make sure before everyone leaves, make sure everyone signs the attendance form.